Alrighty, so now we're just going to pick up right where we left off yesterday. And how do you solve an equation that has two radicals in it? Okay, so all you have to do is get one radical on each side of the equal sign, and then you square both sides. Okay, so let's just do a couple of examples. So let's say we have the square root of x equals 5 radical 3. Okay, so nice and convenient here that we have a radical on each side of the equation. Now, the thing you have to be careful about when you square both sides is that we're going to square this and we're going to square this. And I know that the square root of x squared is x, but I have to square both pieces. So we did this in Math 2 and Math 1, and a lot of times we told students, oh, just write it out twice, go like this and like that, and then you need to multiply those. So kind of a shortcut I want you to think about is just go 5 squared is 25. The square root of 3 squared is 3. Okay. And then we should always check just to make sure that I'm not going to get an extraneous solution. Does the square root of 75 equal 5 radical 3? I'm going to tell you it does, because I don't want to check this one for extraneous solutions, because I don't want you guys taking a ton of notes. Okay, let's look at another type. And this one's a little bit harder. Okay, so let's say I have x minus 12 equals 2, minus the square root of x. Okay, so I've got to watch out when I square both sides on this, because I got to use parentheses here, parentheses there. Okay, when I square that, the radical just goes away and I get x minus 12. This is a binomial. It's got a minus sign. See how that didn't have a sign in the middle? And I just squared each piece? Since this has a sign, I have to write it like this. Okay, so I want you to be really careful with that. Okay, so I'm going to bring down my x minus 12, and I'm going to go 2 times 2 is 4, minus 2 radical x, minus 2 radical x. And I know it's a plus x because the square root of x times the square root of x is x. Okay, x minus 12 equals 4 minus 4 radical x plus x. Okay, so this seems kind of weird because what the heck? There's another radical in here. So now we're going to go back to what we did yesterday. We're going to try to isolate that radical. Okay, I'm going to subtract 4. So it's going to give me, looks like that. Now I'm going to subtract x. Oh, that's nice and convenient. The x goes away. Okay, now I'm going to divide both sides by 4, or negative 4. Phew. And then I'm going to square both sides. We're running out of room. And x is equal to 16. Okay. Now, this one, I'm going to tell you, is extraneous. Look what happens when we plug it in. Okay, so I'm going to plug in 16 right there. That becomes the square root of 16 minus 12 equals 2 minus the square root of 16. Well, 16 minus 12, that's 4. 2 minus 4. So that tells us that the only solution that we have is an extraneous solution. So there is no solution. I just ran out of room on this problem. But you couldn't just write no solution. You would have to prove that there's no solution by going through all of this work right there. I think that's enough for today. What about you guys? Okay, so I'm going to add a few problems. The worksheet that we did yesterday, I'm going to have you do 15, 16, 17, and 18. And then I'm going to add a couple little problems like these at the end, and that'll be it. You guys have a great holiday break. I hope I see you back here on Monday. It'd be so nice to actually meet many of you in person. Not holding my breath, but maybe. All right, have a great week, great vacation, guys. Bye-bye.